So we're talking about Descartes, and so here's the space that we have worked in since forever, right? So it's called a rectangular coordinate system. It's called the XY plane. It's called the XY plane because this horizontal line is the x-axis and that vertical line is the y-axis. We're talking about a unification of algebra and geometry, where now we are going to put numbers on that object, the point, which is the basic element of geometry. And now we've associated it to that point two numbers, and from that, lines, planes, circles, all of these things now have equations, right? And we should not take for granted that there was a time in which we did not do that, that all these geometers were working with all these things with no grid lines, right? Talking about circles, lines, and all this stuff. And algebraists at all, during the same time, were using equations, solving linear equations, talking about quadratic equations, and not thinking of quadratic equations as parabolas, right? But now that we do this, we have this collision of algebra and geometry, which we call analytic geometry, right? Where now we can say the equation of a line, the equation of an ellipse, and so forth. What I would like to offer today is a different way of arriving at point A. There's point A, and we know that in order to get to point A, this is true in Washington, D.C., constructed by Benjamin Banneker and LaFont, of how to get to A. In D.C., everything's numbered in letters and numbers, right? So my house in D.C. is right near 9th and R, right? Literally, you just go the 9th block from the origin and go up to R, and my house is there, right? Here to get to A, we would go up 5 and over 13, right? Or over 13 and up 5, okay? This is called rectangular coordinates, and it's not so shocking why it's called that, right? A is clearly on a rectangle. I want to talk about a different way to get to A. I could get to A another way. I could get to A if you simply told me, if I started at the origin and I use some angles, right? I could do this, and do that, right? That angle is 21 degrees, right? So from the origin, I could just get in Canon, point it at 21 degrees, and now you just need to tell me what? How far? I could get to A if you pointed me at a 21.04 degree angle and fired me 13.93 feet. I could also get to A that way. That's called polar coordinates. Okay. So today we're going to talk about polar coordinates and why they're useful. Have some fun with it. And again, the point of today is to show you that it just exists, right? One of the reasons why I want to talk to you about polar coordinates is it's super interesting, but also, in your work, when you're dealing with circles and other graphs, you might want to consider switching the polar coordinates, right? Where instead of using rectangular coordinates. There are situations where the equations turn out to be much nicer in polar coordinates than what they look like in rectangular coordinates. Questions about that? So we're going to go from one coordinate system to the other. We're going to look at some graphs and stuff like that. Okay. Questions about this alternative way of getting to A, starting at the origin instead of going up and over. Tell me the angle and just shoot me there. Just tell me how far, right? I will go ahead and throw some stuff into Desmos so that we can now see some curves that are in polar coordinates that you would never see in rectangular coordinates. Okay. So I'm going to go back and start talking about functions now in polar coordinates. I want to be clear of how I describe this. Right. You give me the angle, I'll tell you how far to go. Give me the angle, I'll tell you how far to go. So how far to go depends on the angle. How far you go depends on the angle. So we're going to call the angle theta, that's not shocking, and the distance r. And r is a function of theta. You tell me the angle, I'll tell you how far to go. The distance depends upon the angle. So one of the basic graphs is just r equals theta. So you go to Desmos and you switch the coordinate systems to this. Right? So that's the coordinate system. And so now let's see if I write r equals theta. Right? I'm about to put theta. Let's see what that looks like. So when I do r equals theta, and theta is in, it's always in radians. Right? Let's look at a few points on this graph. Here's theta. Here's r, right? So when r is 0, theta is 0. When r is pi over 4, theta is pi over 4. When r is pi over 2, theta is pi over 2, right? I'm sorry, when theta is pi over 2, r is pi over 2. When r is pi, I'm sorry, when theta is pi, r is pi, right? What in the world does this mean? This means that when the angle is 0, don't move any from the origin. When you go 45 degrees, move out pi over 4 feet. When you're at 90 degrees, move out pi over 2 feet. When you're at pi degrees, or in this case, when you're at 180 degrees, move 3.14 feet to the left. Right? You have any idea what this looks like? Yeah, the angle keeps going around, but you keep going around larger. It's a spiral, right? That the larger the angle's going around in a circle, but the distance from the origin is getting larger. So the angle gets larger. The angle is just going around the circle, right? There's the unit circle right there, where the angles, right? But the r, the more you go around, the larger the angle gets in radians. But r is the distance from the origin. So it's going out from the origin. There's no way. The formula for this in a rectangular is atrocious, right? And so, yeah, it's only if you ever want to see a spiral or any pretty thing, right, you have to be using polar coordinates. Let's put some more pretty stuff up here. So when you do something like the cosine of theta, let's put a there and slide a like this. You get something like that. Let's slow it down a little bit. You get that thing. Right, again, something that you just won't be able to see in rectangular coordinates. So the issue is that if you're dealing with stuff that is circular, that is spiral-like, you need to be changing coordinates to something else, right? So you might imagine that, yes, some biologists who want to model flowers or whatever are not working in rectangular coordinates. They're going to want to change to polar coordinates. Any questions about motivation, about how to get the points in polar coordinates? At least the idea of it will now get the formulas to go, if you start with a point in rectangular, what does it look like in polar and vice versa? Oh, that one's beautiful. That is just beautiful. Okay. 99.99% of the time, all of math in undergrad is in rectangular coordinates. There is a time in Calculus 3 where we do stuff in polar coordinates, except for this moment too, in pre-calc. All right, so the question is this. I got a point here. I got this point xy. It's in rectangular. The question now is, what does it look like in polar, right? So those are the two ways of getting to the same point, right? So in rectangular, you go over x and up y. In polar, you go out r distance at an angle of theta. Those are the two ways of getting to the point, getting to this point. And now in polar, it's called r theta. Okay. So now, aliens from another planet who have never seen rectangular, like, what are you talking about? You can clearly get to this point by going out r feet at an angle of theta, and they would be right.
Professor,
Yeah.
quick question. Are you gonna put the homework up on this stuff?
On this,
Like on everything? Like last week and stuff?
everything's up.
It's on YouTube?
Everything's up.
Oh, I didn't see it, my bad.
Yeah, everything's up. Yeah. Yes.
Does the R represent length?
R is the distance from here to here. R is the length of this side. That's right. To get from here to here, you need to go out r feet at an angle of theta. That's right. I'm just going to talk about the relationship between r, theta, x, and y. Right? And that'll tell you how to go from one degree, one system to another. Okay. This is a triangle. This is precisely why it's in this chapter, chapter 7. Right? So this distance is y, this distance is x. Obviously, you go over x and up y, right? And so what trig function relates theta to y and x? Tangent. The tangent of theta is y over x. And so if you have a point in rectangular and you wanted to find the angle, then theta is, how do you move this tangent over here? It's inverse tangent. Theta is inverse tangent of y over x. If I give you a point in rectangular, if you wanted to switch to polar and find the angle, then you would take the inverse tangent of the y coordinate over the x coordinate. Right. R is pretty obvious. It's from the Pythagorean theorem. We know that x squared plus y squared equals r squared, so r squared equals x squared plus y squared. Right. And so if you needed to find, if I gave you a point in rectangular and you wanted to find the distance, you would just take the square root of the sum of the squares. And so what we've just derived is rectangular to polar. Rectangular to polar. Right. Right? If I give you xy, then r equals the square root of x squared plus y squared. That'll tell you how far to go out. And if you needed to know the angle, it's the inverse tangent of y over x. That is how you go from rectangular to polar. First few problems on the homework. I give you a bunch of points in rectangular. You have to write them in polar. Those are the formulas to use. Polar to rectangular, suppose I told you now, let's put the same diagram up. Here's the diagram. Well, let's just go down a little bit. So, I'm sorry. Do we have this now? Okay. So that if I give you the same diagram now and I gave you the polar, I told you that here's the angle theta, here's r, and I don't know what y and x are, right? What trig function relates theta, y, and r? Sine. So the sine of theta is y over r. So if I gave you r and theta in polar, the y coordinate would just be r the sine of theta. For the same reason, what do you think the x coordinate is? What trig function relates theta, x, and r? Cosine. The cosine of theta is the adjacent over the hypotenuse. If I gave you r and theta and you wanted to know the x coordinate, it would be r cosine theta. And so to summarize, to go from, if you deal with these aliens who are talking in polar coordinates, if I gave you r and theta and you wanted to switch to the human rectangular coordinates or Cartesian coordinates, then you would just say, well, x is r cosine theta and y is r sine theta. That's how you switch from one to the other. Questions there? I want to talk about extending, doing a little bit of plotting with rectangular coordinates. I'm sorry, with polar coordinates. A negative r, so you might see the point -3 comma power of 4, right? Let me graph, so here's an example. Right. Let me start off with a nice one. Tell me about the point 10 comma power of 4 in polar. How would I get to this point? Make an angle of how much?
45.
Say it again?
5.
45, that's right, power of 4, and go out how far?
10.
10 units. Is that okay? So you might see, when I see -10 power of 4, right? So when r is negative, reflect through the origin. Go back in the opposite direction. The minus sign represents going in the opposite direction of where it usually is, right? So instead, -10 power of 4 means make an angle of power of 4 with the x-axis and go back 10 units in the opposite direction. So the minus sign on the r just means go in the opposite direction of what you normally would go. Obviously, negative angles means that you go backwards, right? Instead of going the usual way on the unit circle, if this was -4 comma -pi/6, you would go 30 degrees backwards and then go back. What quadrant is this in? What quadrant is this point in? It is in quadrant 2, right? Because this takes us to quadrant 4, and then you go backwards through the origin to quadrant 2. You go on the opposite side of the origin. Okay, so that extends these points to be positive and negative. I think that's it. We're ready to hit the homework. We're going to do some translation from certain points to other points, look at some points and pick some graphs, and then we'll move on and review for the test. 5, 135 degrees, that is currently in polar coordinates. What quadrant is that in? 135 degrees. Go 135 degrees out, 5 miles out, 135 degrees. What quadrant? 2 for sure. It's kind of similar. Go out 135 degrees, but go backwards. What quadrant is that? 4. So it's like you're doing this. Here's 135. Right, so this is 10, 135, right? I'm sorry, 5. Let's do 5. 5, 135 is here. Right? But then -7 takes us back in this direction. Right? So here's -7, 135. All right, go out 135, but go backwards. 4, 5 power of 3. Right, so when this is positive, it's just the same as a unit circle. Where's 5 power of 3? Quadrant 4, right? Quadrant -8 power 4. Quadrant 3, right? So you go out power 4, but in the opposite direction 8 miles, quadrant 3, right? Pretty straightforward. We're burning through these. What quadrant is that in? So that's just minus power 4. Let's go back. Power 4 units down and 3 out. Quadrant 4. Just looking at where points are. Where is that? Quadrant 2. Right, so go back. Power 4 units takes us there, but then go in the opposite quadrant of that because of this minus sign. So this minus sign means go backwards. This minus sign means reflect over the origin. It's looking at points in a new coordinate system. Which is which? Which point is 5, 2, 25? Right, so here's 180, a little bit more than 180, and out 5 units. 7 power 4. So again, you can have the circle out for this thing, right? You just find what 7 power 4 is. 7 power 4 is in the 4th quadrant. Then we're reflecting that over the origin, puts us back in the, oh, the point. Yes, the point is here, right? So the original angle is here, and then they put the point out here, right? So they're naming the original angle and then putting the point here. It's going to be interesting which one they want between these two. I think they want this one, right? But it'll be interesting. Yeah, I can't wait to see which one they pick. Let me answer for that. 5 comma power 2. Power 2 is 90 degrees. This one? Perfect. 3 comma negative 45 degrees. 45, I like it. Negative 5 comma negative 2 power 3. All right, so negative 2 power 3 takes us here, right? And then reflect over the origin. B. So go backwards to 2 power 3, reflect over the origin. It's got to be B. Five comma 315. 315 is definitely 4th quadrant, right? Yeah. So a ton of these we'll just burn through. Convert to rectangular. All right, find the rectangular coordinates for these. We have formulas for this. So it's currently given as r and theta, x equals r cosine theta, y equals r sine theta. We have both r and theta. R is 2, theta is 5 power 3. This is the circle for days. X is equal to 2, the cosine of 5 power 3. Y is equal to 2, the sine of 5 power 3. We're talking about 2 times the cosine of 5 power 3 is 1/2, and 2 times the sine of 5 power 3 is minus the square root of 4/2. 1 comma negative the square root of 3. Same thing. Negative 3 cosine of pi. Right. Negative 3 sine of pi. 3 comma 0. Cosine of pi is negative 1. There you are in rectangular. What is it in polar coordinates? All right, we got the formulas. Theta is inverse tangent of y over x, and r is equal to the square root of x squared plus y squared. X in this case is -10, y is 10, theta is inverse tangent of 10 over -10, inverse tangent of -1. R is equal to the square root of 200. 100 squared plus 100 squared, 2 square root of 10. Right. Polar coordinates are r theta, so r goes first. 2 square root of 10, comma, what's that angle? Inverse tangent is -1.
I think it's the other line. 10 square root of 2.
Say it again. Oh, 10 square root of 2, thank you. It's 10 square root of 2, thank you. So it's 10 square root of 2, comma, what's that one going to be? -45 degrees, negative pi over 4. You should probably put it in degrees so you can see it in degrees. It's not going to look nice in radians, right? Negative pi over 4. They want the angle to be between 0 and pi and 2 pi. What angle do we choose there then? So they're not going to take this. Okay. So what angle is going to do that? That's on the first go around of the circle. 10 square root of 2, comma, what angle is that? 5 pi over 4. They're going to want this one. Only because they said here they don't want negative angles. They don't want negative angles. So the angle that corresponds to negative pi over 4, that's in the same place, it's 5 pi over 4.
Not the same thing, please?
Say it again.
7 pi over 4.
Oh, it's there. That's right. It's in the fourth quadrant because the tangent's negative. That's right. The tangent is -1, so it's in the fourth quadrant. That's right. Yeah. So obviously, minus pi over 4 is here, and that's the same thing as 7 pi over 4. Same thing here. This is in rectangular coordinates, and so x is equal to -6 square root of 3, y is equal to 6. Go through the work. Inverse tangent of, and here's where you definitely want to put it in degrees, right? Inverse tangent of 6 over -6 square root of 3. If you put your calculator in degrees, it'll tell you this nice number in degrees, and you can switch it back to radians. If you have it in radians to start, of course, that involves pi, which is irrational, no calculator, at least not the TIs, will give this to you nicely. It's either some variant of 30 or 60, right?
Negative 30?
Negative 30 degrees. Right? So negative 30 degrees is negative pi over 6, right? And so, again, they don't want negative values, so they want instead 11 pi over 6, which is 330 degrees, but they want it in radians, right? So 11 pi over 6, and then that's the angle. And so we just need to find the distance. The square root of -6 square root of 3 squared plus 6 squared equals, this is a funky 108 plus 36, a beautiful 144, 12. Okay. So again, what we're saying is that if you wanted to get to this point, you could, and actually, this one's harder, right? Right. So you would say, go go down minus 6 square root of 3, go to the left, negative 6 square root of 3, and go up 6. Or you would say go out in that direction, right? So let me see here. So this, I'm not happy with this, right? Because this is clearly in the second quadrant, right? This pointing us in the second quadrant. So yeah, so here we have to make a decision. So it's not 11 power 6.
It could be if you put the 12 to minus.
Well, so now this is the problem is we have to pick the right coordinate. So what's the other option? What's the other place? The other place is 5 pi over 6, and that's clearly the one we should pick. All right, so for these we have to be super careful. How do I know? So here's where the problem is, right? The problem is you do the inverse tangent in the calculator and you get negative pi over 6, right? So you get negative pi over 6. They don't want negative pi over 6. And so this is deceptive, right? Because we already said that your calculator has been programmed to give you angles between minus pi over 2 and pi over 2. The only thing you should take from this is that the answer is over 6. Okay. And so now you need to just find the angle in the second quadrant that's over 6, and it's 5 pi over 6. And that's the angle you should take, right? So once you get minus pi over 6, then you just need to say, well, what's the quadrant? And here it has to be in quadrant 2 because we had a negative x and a positive y, right? And so it was quadrant 2, and then you take the angle in quadrant 2 that's over 6. And that'll take you to the place. Go ahead.
With the, because the square root, it's got positive or negative number for the exponent.
Yeah.
Would you just take the negative number to be easier? Or?
Oh, no, they wanted r to be positive.
Oh, okay.
Yeah, it's only because they asked for r to be positive. Yeah. Where is that? I'm sorry, it was here. It was earlier, right? So it was here. They wanted r to be positive. Yeah. So yeah, that's tricky. That's tricky.
So you have to look at the
Denominator.
first quarter.
I'm sorry, say it again? Yeah, you just have to look at, you have to see what quadrant we're in to start, right? So we're in quadrant 2. And then when you do this inverse thing, it may not give you the angle in the right quadrant. And so you have to pick the corresponding angle to that's in the correct quadrant. So your calculator is going to tell you pi over 6. That's in the fourth quadrant, but you need something in the second quadrant, and you have to pick the angle appropriately. You have to pick the angle that's over 6 in the second quadrant, and that's 5 pi over 6. That's the issue. Go ahead.
When you did the inverse of tangent, I got negative 60, not negative 30.
I was trusting somebody. What is the inverse tangent?
I got one
It
right.
was 30 on mine.
Yeah, I got 30 as
I
well.
got negative 30.
Right.
Oh, so that's correct. All right, never mind. I guess
Okay. Inverse tangent of 6 over, yeah, okay. So here's the other problem. If you put in inverse tangent of 6/6 square root of 3, it thinks, I'm sorry, there's a minus sign here, right? It thinks you have put in -1, right? It thinks you have put in -6 over 6, the square root of 3. So, right, so if you didn't put parentheses around this denominator, it's going to do this. And that is 30, right? I'm sorry, that is 60, right? So you have to, so if you put parentheses around this, it's going to do it correctly. Well, somebody made a mistake. Maybe everyone else did that and you did it right. Okay, so make sure you put parentheses on the denominator and then you should get the right thing.
Yeah.
Yeah, so it's all about the parentheses there. Yeah. Okay. That's it. That's cool. All right, so any questions about polar coordinates? Just formulas, you know they exist. They're pretty. If you want to make a flower for your significant other, it should be in polar coordinates, right? So, yeah. All right. We can take a break, or we can burn through the practice and end early.
Burn through the practice.
Let's do it. Practice exam is chapter 6 and the first part of chapter 7. You know, for chapter 7, we'll just be solving some triangles. Chapter 6 and chapter 7 practice test. Number 1. Oh, I think it's like 17.
Oh,
Is it 18?
she already scoped it out.
Oh, yeah.
Yeah, 18. 18. Sure. All right. Should we take a 2-minute break? No, no. Gangster, let's get it. I love it. Number 1.
Already two.
We're going to be solving trig equations. Can we see that? Let's make this larger. All right, so here, let's get the steps out for this. You want to find the angles that give you the square root of 3 over 2. Here, what we'll need to do is we'll need to look at the circle. Give me a chance to scroll down, right? So I got cosine 2 theta equals the square root of 3 over 2. This can happen only in a couple of places. You would look at the circle and say that the thing inside the cosine needs to be equal to what? Pi over 6 plus 2n pi. Or what's the other place? Is it 11 pi over 6? That's 2n pi. Okay. Questions about that? Right. So all we're doing is looking for angles where the x-coordinate is the square root of 3 over 2. If you have the circle in front of you, you'll see that those two angles are pi over 6 and 11 pi over 6, right? And so we know also that if we're looking at all the solutions, you can just keep circling around the circle as often as you need to, right? We are bounded by 0 to 2 pi, right? So I only want the answers that are in this interval. And so then we're just going to pick values of n to see how many stay in the interval 0 to 2 pi. All right. Questions about how we get here so far. So you're given that, go to the circle to get both of these angles, right? The thing inside is 2 theta, and so we want to solve for theta, so we're going to divide everything by 2, right? And so then we got pi over 12 plus, divide that by 2, that's an n pi. And then over here, let's just separate this. We got theta is an 11 pi over 12 plus n pi. Just cut everything by 2. And at this point, we start picking values of n that will keep us in the interval 0 to 2 pi. When n is 0, you get a nice pi over 12. That looks good. When n is 1, the question is, will this stay within one rotation of the circle? Pi over 12 plus pi is 13 pi over 12. That is perfect as well. And if you dare do another one, it wouldn't work. Same thing over here. Looks like we're going to get 4 answers. When n is 0, you get 11 pi over 12, which is all good. And when n is 1, you get we barely make it. It's 11 pi over 12 plus pi, which is a 23 pi over 12, which is as close to 2 pi as you can get, but it is not more than 2 pi. All 4 of these angles are solutions to this, and they're in the circle. Theta equals pi over 12, comma 13 pi over 12, comma 11 pi over 12, comma 23 pi over 12. 4 answers. The off-the-record remark is that this is not so shocking. There were 2 answers to start, and now that I put, if I just had cosine theta, there would be 2 answers. But obviously, when I do cosine 2 theta, it doubles the number of solutions, because you get through the thing in half the time. So you're going to get 4 answers to this. Solving this thing, oh, well, oh wait. We'll see. Okay. There's the H4. This will be fun. Use an identity to solve this. Let's add a page. All right, let's remember some of these identities and figure out which one we want to use best. All right, so we got the sine of 2x. So our cheat sheet game is better be good, right? So if you just use the cheat sheet off the web, you'll just have jumbled formulas all over the place. There are a few set of formulas that you should have on your own cheat sheet that you write yourself. This should be one of them, okay? That's one, and then cosine 2x. Well, we got a number of choices here, right? It's cosine squared x minus 1. It's 2 cosine squared x minus 1, right? It's 1 minus 2 sine squared x. It's cosine squared x minus sine squared x. Okay. So we're trying to figure out which one to use here. Let's just try something. So it's 2 sine x. And what we probably want to do is write everything in terms of one thing, right? So let's see, 2 sine x cosine x, right? That's that, times cosine x plus, and let's use this one. 1 minus 2 sine squared x times sine x equals minus 1/2. Let's try that. That gives us 2 sine x cosine squared x, and then plus sine x minus 2 sine to the third x equals minus 1/2. Right? And then we could change this cosine squared to 1 minus sine squared. So 2 sine x times 1 minus sine squared x plus sine x. I know. Minus 2 sine cubed x equals negative 1/2. Let's see what happens here. Make sure that we're good here. So this was given, cosine squared is 1 minus 2 sine squared. I'm liking that. That's all good. All right, so what happens? So then 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x equals minus 1/2. Still not liking this. There must be an easier way to do this. Go ahead.
I'm just saying.
Yeah, it's super ugly. Yeah, there must be an easier way to do this.
There's a lot of 6-5 on the test.
Yeah.
Is there a way we can actually
There's a way to go ahead.
do it in MATLAB?
Yeah, this has an ID. Yeah, I just want to. I'm thinking about taking this one out. Yeah, so. What'd you say?
Blessings.
Yeah, so. Because the problem is that something might cancel out nicely. but it's not obvious what it is, right? So we could do, so this turns into 2 sine x cosine squared, and if this was, so if we change this to, okay, so if we did this, right? So this would be 2 sine x cosine squared x, and if we change this to 2 cosine squared x minus 1, then this would be plus 2 cosine squared x minus 1 times sine x, right? And then, no, the signs are still wrong. So then it becomes, yeah, nobody wants to do this, right? So then it becomes something like this. It still turns out to be the same thing. I think we are going to take this one out. So, yeah, so let's make this extra credit. It's not obvious to me upon first look how to do this in a nice way so that things cancel out nicely, right? So, even or odd.
If you go odd, you're gonna do like 3.
That's exactly what I was going to say.
Maybe you should double the odd.
That would make it even if you said odd.
Even.
Even, we'll make it 6.
6 points.
Yeah, we'll make it 6 points. Yeah.
If we solve it.
On this test or?
On the next one, yeah. On the next one, yeah. Go ahead and solve that. I'm interested to see what's the nice way to do this. This is in my math lab somewhere, so it'd be nice for you to just write out so I can take a look at it. Easy points. Yeah, that'd be interesting to see. It's probably gonna be something that's maniacal. Number 2 we'll take out. Number 3 we'll solve this triangle. Wait, it can't be there, right?
Yeah, it is.
Are these must be out of order. I guess they've been put out of order. Okay, so I wanted to go in order, but it's okay. I guess they're being scrambled right now.
Yeah, they're scrambled in ours too.
They're scrambled?
You scrambled last time too.
Did I? No.
You scrambled
On the test?
You didn't scramble the first test, and then you scrambled the second test, and this.
I did not mean to scramble. No, I think it scrambles by default. And I just need to uncheck the scrambling. Do we like the scrambling?
We don't like the
No.
scrambling.
Okay. Yeah, I did not mean to do that.
Please speak
Yeah.
for us.
That's right. That's right. Okay, so I will make sure this is unscrambled right now because it's going directly to chapter 7. As you can see, yeah, so it's 7.1.1, right? And again, if you want to practice the other one, I'm sorry, if you want to practice the other one, the one for extra credit to see how to do it, then it has ID 6581, which means it is not a joke. Right, it is the 81st problem and a 6.5 study plan. So if you go to study plan, go to chapter 6, section 5, problem 81, you'll see this, and then you'll see how to work through it. Yeah. Okay. Here we're using, oh, which one is it? This is a good idea. Which one is it? Is it the law of sines or the law of cosines? Let's take a look.
I think it's a lot of times.
All right, so let's see here. Yeah, we'll see in a second. We got a triangle here. I got angle, side, angle, law of sines. Angle, side, angle, law of sines. We did this last time. Is that 36? Is that 77?
Yep.
36, 77. What's left?
113.
What?
That's-
What's the remaining angle? Oh, that's 113. Oh, okay. I thought you said that was the remaining angle. Right, 67 degrees is this angle.
67.
Right.
Like that.
No worries. Questions about how to get the third angle, add up to 180. All right, sine of 36 degrees over, is that 7?
Yes.
equals the sine of 67 over b, cross multiply, b the sine of 36 degrees, we did all this stuff last week, equals 7 the sine of 67 degrees. And so b is 7 sine of 67 over the sine of 36. We mentioned this before. My math app is clear about this. Do not round to the final answer. I know we're tempted to maybe round this. Again, the moment you round and then do computations with a rounded number, the more incorrect it gets, right? The more decimal places of accuracy you lose, right? So just learn how to put that thing in the calculator at the very end. We need one more side. That's for angle C, which is 77 as an opposite angle. The sine of 36 degrees over 7 equals the sine of 77 over little c. And again, little c is equal to, we do this enough times, 7 sine 77 over the sine of 36. The other thing to take into account is just to be careful that you're in radians and degrees at the right moment. Right? So for all that trig solving stuff, all that stuff is in radians. Obviously all this triangle stuff, you should be in degrees. Right? And again, for these it makes sense, right? That whatever numbers you get have some relative size comparison to the number 7, right? If 7 is opposite 36, then you should expect some 8s, 9s, 10s, 11s, right? You shouldn't be getting 0.33, right, for the side of this triangle at all. Okay. Oh, questions about it? Someone want me to go back?
Can you go back to the C?
Yeah.
Thank you.
Yeah. Are we good?
Yes.
Okay. So then here, flat out calculator. Use the calculator to solve this equation. Sine of x equals that, right? We need to do the inverse sine. X is going to be inverse sine of negative 0.8919. It needs to be in radians. You need to take that. That's automatically going to be in the fourth quadrant as a negative angle. And then you need to add 2 pi to make it within this interval. Right? So again, the calculator is programmed to throw this angle in the fourth quadrant, and to put it in the correct quadrant, you need to add 2 pi to it. What does the calculator say here? Say it again? No, what is this on its own? Negative
0.15.
I'm sorry, negative 1.0.
Oh, 1.1015.
Okay, and then you add 2 pi to that, and then round to 4 decimal places.
Is that why the calculator is in degrees? Or?
Right now, the calculator should be in radians. Right. So yeah, maybe we need to just let people know. So this is in degrees. Right? This one's in radians. And how did you know? What gave it away that this one's in radians? That's 2 pi, right? And type your answer in radians. It's right there. That was testing whether you know. This one's flat out from the homework. All right, so you need to write this as a quadratic involving sine. Right. Cosine squared is 1 minus sine squared. This gets this whole thing in terms of sine. So you use a trig identity to switch cosine squared to 1 minus sine squared. 2 minus 2 sine squared x minus sine x minus 1 equals 0. Minus 2 sine squared x minus sine x plus 1 equals 0. Distribute a minus sign through the whole thing to make it a nice quadratic. Like that. and then we can factor nicely, right? So then it's this, it's 2 sine x, it's sine x, it's minus 1 plus 1. So then sine x needs to be 1/2, or sine x needs to be -1. And then we're talking about all from the circle. Looking at the unit circle, the angles that are on the first go around, 0 to 2 pi, where the y coordinate is 1/2, are pi over 6, and the other one is 5 pi over 6. The angle where the y coordinate is -1, 3 pi over 2, all from the circle. And they want them here, and they want them in radians. Right, so trig identity, distribute, factor, and that's the game. That's almost identically the same thing, right? It is the same thing, right? Yeah, so same thing, same answer, everything. So sine theta. Hopefully your algorithm is just as nice to you, to give you the same problem again. -1 plus 1, same answer. Again, you can practice here for other types of problems. On your cheat sheet, you should definitely have cosine, the sum and difference identities. So the cosine of A plus B is cosine A cosine B minus sine A sine B. That's the one we're using here, right? And so A in this case is 60. B in this case is 225. It is not coincidence that all of those angles are on the circle, right? And so then this is the cosine of 60, the cosine of 225, minus the sine of 60, the sine of 225. Looking at the circle, we're talking about, that's 1/2, right? That's negative square root of 2 over 2. That is the square root of 3 over 2. And this is negative, I'm sorry, that's positive square root of 2 over 2. Oh no, that's the third quadrant. Yeah, that's minus as well. We're simplifying a little bit. 1 times negative square root of 2 over 2, so this is minus square root of 2 over 4, minus the square root of 6. And this is plus, right? So positive times a negative, and then a negative times a negative. And that's the answer. That's the sum identity. And then the difference identity, you do exactly the same thing and use the circle again. So then we're talking about cosine of A minus B is cosine A cosine B plus sine A sine B. You just do the same thing except you're doing it in radians. Right? So it's the cosine of 7 pi over 4, the cosine of 11 pi over 6, plus the sine of 7 pi over 4, the sine of 11 pi over 6. Right. 7 pi over 4, that's fourth quadrant, square root of 2 over 2. That is pi over 6, it's going to be, that's 30, so that's the square root of 3 over 2. And then that's also the square root of 2 over 2. That needs a minus sign. And then that's got to be the other one, fourth quadrant, that's times minus 1/2. Square root of 6 over 4 plus the square root of 2 over 4. So use the identity plug-in, and it comes out. Halfway there. All right, hardest ones on the test. off the record about this one. We did one like this on the homework. We saw that there were two triangles that worked here. We wrote out the steps for this. We'll do it one more time. We've got A is 15, B is 16, A is 51 degrees. So a couple of things we need to check, right? So we need to check the height. So first of all, we notice that A is less than B, right? So there could be two triangles or 0, either they're 2 or none. And all it depends on now is whether A is long enough. A has to be longer than the height of the triangle. So A has to be larger than the height. And the height is B, the sine of A. That needs to be in degrees for sure. Right. What is that? I think last time we got 12 something. What is it?
Right, 12.43.
12.43. All right, so now A fits the minimum requirement, so there are going to be two triangles. We're going to use the law of sines to get one set of three triangles, and then we're going to look at angle B and see that angle B, we can actually, take 180 minus that, and that's the new angle. And then get a new angle C, and then get new sides corresponding. That's the game plan. Okay, so you check these conditions, and once you see what the two triangles are, do one set, and then go focus on angle B and change that angle. All right, let's get it.
So if you get the angle B, and if you subtract by 180,
That's the new angle B, get the new angle C, and get the new sides. Yeah, that's the game plan. Because angle A has been set. It wouldn't be angle A that we would change, because angle A has to be 51. So it's angle B that we're changing, and we have no idea what angle C is yet. So. All right, so then we've got 15, 16, 51. 15, 16, and it's angle A that's 51, right?
yeah.
Okay. So then we know that the sine of angle B over 16 is equal to the sine of 51 degrees over 15. We're going to need our calculators in a second. That's it, right? Yeah. So sine of B equals 16, the sine of 51 over 15, and we need the inverse sine of that. B is inverse sine of 16 sine 51 slash 15. That's exactly how it goes in TI. Is that okay? And that's approximately, round to the nearest degree. Is it 56? It's 55.1. Yeah, okay. How are you telling me 55?
He dropped it.
56 degrees. Okay. We made an argument last time that, again, if you're trying to make this triangle, right? You're trying to make this triangle and A is shorter than B, then again, you get to swing A over in this direction, like this, right? And so if this was, what was A again, 51? If that's 51, then that's 51, right? I'm sorry, 56, that's right. That's 56, and that's 56. Then this new triangle here that also counts as an answer simply has the angle that is the supplement. Right? So then your new angle, once we find it out, I guess we can make this remark over here, that when we find the other triangle, then it's just 180 minus 56. We'll do that in a second. All right. So now we have 56 for our first triangle. That tells us what C is. We're talking about 51, 56. What's left over? 73. So C is 73. And then now we can get little c. Right?
I think they asked.
Say it again?
I don't know.
I think they asked for everything.
I didn't think they asked for C.
What?
Yeah.
No, they did.
They did?
They wanted, they want everything from the first triangle and everything from the second triangle. Yeah. Yeah.
They didn't want a B, sorry. They wanted, yeah. Gotcha.
I think they just want everything. Okay.
B was given, sorry.
Oh, okay. I see what you're saying. I think. So C is 73. So then the sign of 51 over 15 is the sign of 73 over little c, and C is equal to 15, the sign of 73 over the sign of 51. And then that's your first set of values. So then B2 or B new, right? B2 is 180 minus 56. That gives us 124. Right? So now we've got 51, 124, and we can squeeze in 5 degrees for C2. That's how much is left in the 180. And then we go about the business of finding the other sides and angles, right? So then you would do sine of 51 over 15 equals the sine of 124 over little b. And then you would do the sine of 51 over 15 equals the sine of 5 degrees over little c, and find those like we've been finding them. Right? And that'll give you the second triangle. Questions on that? Again, not the hardest, but certainly the longest problem on the test. Here I'm trying to hide, just use a trig identity, the cheat sheet.
Can you
This,
go back?
oh, thank you. I appreciate
Go
that.
back.
Yeah. Is it here? Is it here? Yeah. Yeah, so then I can't help it. This means that little b is 15, the sine of 124 over the sine of 51. And this means that little c is 15, the sine of 5 degrees over the sine of 51. Again, make sure everything's in degrees. Yeah. Trig identity here, this is just the tangent of 50 plus 10. This is really just the tangent of 60, right? So we're using that the tangent of A plus B is equal to the tangent of A plus the tangent of B all over 1 minus the tangent of A times the tangent of B. Just screaming to you a trig identity. And then they want you to write that as the angle and then write that in terms of square roots. And so go to the circle, we need the y coordinate over the x coordinate. The y coordinate at 60 degrees is the square root of 3 over 2. The x coordinate is 1/2 the square root of 3. So that would be pretty easy, just referencing on your cheat sheet a trig identity. The y over the x coordinate. We're solving 2 cosine 2x minus the square root of 2 equals 0. 2 cosine 2x equals the square root of 2. The cosine of 2x equals the square root of 2 over 2. We did one like this earlier. This is almost being redundant, so I might take this one out as well. So we need to find all the angles where 2x is equal to pi over 4 plus 2n pi, or 2x equals, what is the other place? It's 5 pi, I'm sorry, it's 7 pi over 4 plus 2n pi. Those are the places on the unit circle where the cosine is the square root of 2 over 2. Right, so this is all from the circle. The circle tells us that that's what's supposed to happen. And then we'll go ahead and divide everything by 2. So x should be pi over 8 plus n pi, or x should be 7 pi over 8 plus n pi. And we just need to check which n's are legal to fit us inside the interval 0 to 2 pi. When n is 0, you get x is pi over 8. That looks okay. When n is 1, you get x is equal to pi over 8 plus another pi. I like that. That's 9 pi over 8. That fits on the circle. 7 pi over 8 when n is 0 here, right? And then, by the way, when n is 2, it's over, right? This is too much. When n is 0, you get 7 pi over 8, and when n is 1, you get 15 pi over 8. Right? So this is so close to the other problem in terms of how to solve it. But again, yeah, I might take this one out. 4 answers, I'm going to put them in red. Pi over 8, 9 pi over 8, 7 pi over 8, 15 pi over 8. And there were 2 answers originally. We doubled the number of answers here. Conceptually, we can always use the law of sines to find missing parts of a triangle in which 1 blank and 2 blank are known.
One side, 2
One side, 2 angles.
angles.
One side, 2 angles. In other words, angle, side, angle. As long as you have angle, side, angle, you are good to go for the law of sines. Side, angles. It's giving away points. Same thing. I don't know how many times I can ask you the same question.
6. 6, 5 was really difficult. You asked 6.
Okay. So 4 cosine squared x equals 2. Cosine squared x equals 2 over 4. Cosine squared x equals 1/2, right? Cosine x equals plus or minus 1 over the square root of 2. Cosine x equals plus or minus the square root of 2 over 2. Right, so I just want all the angles where you get square root of 2 over 2 or negative square root of 2 over 2, and that's just all the angles over 4. You're just getting cosine by itself, solving for it, taking square roots. Here, I just want you to flat out use the formulas, right? Nice and ugly. Alpha's got a triangle that looks like, so what I want to do, here's the game plan. I need to find the sine of alpha, and I'm going to find the cosine of beta, and we're just going to use the formulas. Okay. So we got a triangle here that goes, here's alpha. The cosine of this angle is adjacent over hypotenuse. This has got to be what? 4 blank 5? Blank 4, 5 triangle. What number is that? It is 3. That's right. So the sine of alpha is opposite over hypotenuse, and we just have to make sure we're in the right quadrant. What quadrant is this? Quadrant 4, negative. Beta we're talking about opposite over hypotenuse, this ugly thing. Z squared plus 16 squared, Z squared plus 4 squared equals 11 squared. Z squared plus 16 equals 121. Z squared equals a serious 105. Z is plus or minus the square root of 105. Put the square root of 105 here. We want to know the cosine of this. The cosine of beta is adjacent, square root of 105 over 11. The quadrant is quadrant 3, and so it's negative. So at this point, it's all formulas now, right? Here you got to do cosine alpha, cosine beta, minus sine alpha, sine beta, and simplify, right? This one is sine alpha, cosine beta, plus, and it's going to be sine beta, cosine alpha, right? And you have all these numbers, right? So they're all here. Let's just make sure we've outlined them. So the green is perfect. There's cosine alpha, there's sine beta. So the only challenge probably is making sure you don't mix up any of them. So again, some of your calculators will do all this work so beautifully for you, right? So to just go ahead and plug the stuff in the calculator and just plug in all of this stuff. And whatever you get for A and B, just divide to get the answer to C, right? So this one is the answer to B, B divided by the answer to A. Just take the ratio. Tangent, sine over cosine. So we're talking about 4 over 5 times the cosine of beta minus the square root of 105 over 11, and then minus sine alpha, which in this case is plus 3/5, times sine beta is negative 4 over 11. Minus 4 square root of 105 minus 12 over 55. This was going to be something similar, also over 55, right? And when you put one over the other, the 55s cancel, and then it's going to be nice for you, right? Sine alpha minus 3 over 5, cosine beta is minus square root of 105 over 11. Sine beta is minus 4 over 11. And then cosine alpha was given as 4 over 5. Let me just simplify. Questions there? Creating two triangles. Say it again.
The negative 4 over 11.
Yeah, thank you. So this negative 4 over 11 was the sine of beta. The sine of beta is this one. So sine alpha, this. Cosine beta, that, and then plus sine beta, but sine beta was a negative 4 over 11 times the cosine of alpha, which is 4 over 5. Right, so sine alpha.
That's to get C.
That's to get B, right? And then once you get A and B, you simply take this. So if you work this out, you get 3 square root of 105, right? Minus 16 over 55, right? And then once you get, so now you have B, and now you just take this and divide it by this. The 55s cancel, and it's just this over this, right? So the tangent is going to be it's 3 square root of 105 minus 16 all over minus 4 square root of 105 minus 12, right? It's just this numerator over this numerator because the 55's cancel. Yeah, now when they say rationalize do they say rationalize denominators? Yeah, it'll be interesting whether they'll want you to, yeah, I'll be ready. If you put this in, and they don't take it, I will mark it right. Because, yeah, we don't have time to rationalize that. That's going to take forever. Okay, so create 2 triangles, get the other angles, and then use the formulas and do a ton of algebra. Couple more. Another triangle. Looks like there's only going to be one. Okay. Law of cosines. A is bigger than B. So it's either just one triangle or 0 if this is not long enough. The height again is 2 the sine of 50, right? And of course that is less than A. That's less than 6 by miles. And so we're good to go. There's going to be one triangle that solves this, and we'll burn through this one pretty quickly. So the street version is that once you see that, yeah, the off-the-record street version is that once you see that A is bigger than B, you probably don't even need to check the height at all. Once A is bigger than B, there's going to be one triangle, and yeah, you just go find it, right? The sine of B over 2 equals the sine of 50 degrees over 6, right? So the sine of B equals 2 the sine of 50 over 6. B is inverse sine of 2 sine 50 over 6. Now, I, again, am worried about parentheses. I would write it like that. That gives you B, and you already had capital. So first of all, you would click this one, right? There's one triangle. That'll give you B, then C is going to be the remainder amount, and then you go get little c by doing this again. Right. And then, as you might expect, there are 3 problems using law of sines. Right? So there'll be one where there are 2 triangles, one in which there are no triangles, right on time. Right? This one should be no triangles. It just looks like this is too short. Right? So if you look at B, the sine of 60 degrees, plug that in the calculator. B is 28. 28, the sine of 60 degrees. It looks like 20 is too short for that. Let's test it out. 28, the sine of 60 degrees. In degrees is
24
point whatever. That's greater than 20. That means that that this side is too short. It's shorter than the smallest possible length it could be, which would be the height of a right triangle. So the answer is C. Okay. And so you'll see this pretty quickly when you see that A is, you know, in the earlier one, here's the way off the record remark. In the earlier one, when A was shorter than B, it was just a little bit shorter, right? It was 15 and 16, right? And even when it was 15 and 16, we barely got in another angle that was 5 degrees to get the other triangle, right? 20 is so much less than 28 that you should be skeptical whenever you may see this. Although now they're going to be in order, but yeah. Questions there? Yeah, someone needs to remind me to change that and put them in order. Yeah, I think we're scrolling down, right? 17. Oh, 17, these are conceptual. If A, B, and C are the measures of the angles of a triangle, and little a, little b, and little c are the lengths of the sides of the opposites of these angles, can you say which one is the law of sines? Which one is it?
The second one?
It is the second one. Now, the way that I approved it, it was natural for me to put all the angles up top because we were using the area. We were showing that all the areas of the triangles, no matter how you laid them down, was the same. But people like putting the sides first and the angles at the bottom. It doesn't matter. It's all saying the same thing. But yeah, the point is that little a and capital A, little b, capital B, little c, capital C are all on the same sides of the equal sign. And then finally, true or false. A triangle in which two sides at an angle opposite one of them, side angle, will always give you at least one triangle. Right? That's false, right? Yeah, so that the statement is false. What's the reason? Because, oh, by the way, let's define oblique. An oblique triangle is a triangle without a 90-degree angle. So we had claimed that we were going to solve the triangle when there was not a 90-degree angle in it, right? So let's see if it's B. The statement is false because an oblique triangle in which two sides and an angle are given results in an ambiguous case. The result may be one triangle, two triangle, or no triangle. I really like B. What could D possibly say? The statement is false because an oblique triangle in which two sides and an angle are given always results in a situation. No, that's crazy. Right? So B. And I believe that is it. Okay. So go ahead and take a look at that. The video, and yeah, and let me know if you have any questions. Do the 9th at midnight. I'll try and have this up in the next couple of days.